projects. In this video, we are going to explain about computing with nearby mobile devices, a work sharing algorithm for mobile edge clouds. Introduction. The project focuses on the concept of mobile cloud computing, which involves doing tasks using the computing capacity of mobile devices and their users. This specific mobile cloud is referred to the project as the mobile cloud. The study describes a framework for job sharing among autonomous local mobile devices in order to improve performance and save energy. The project also explores mobile computing concerns such as unpredictable disconnections and frequent swings in resource availability, and offer fault tolerance approaches and work theft strategies to overcome these issues. The project indicates that the suggested framework can result in enhanced speedups and power savings, as well as mathematical performance constraints. Objective. The project's goal is to develop a novel strategy for lowering execution time and energy consumption in mobile edge cloud systems by distributing compute tasks to adjacent mobile devices. The Honeybee design involves a delegator, source mobile, and workers in job sharing mechanism. The delegator offloads duties to the adjacent mobile devices, keeping them in a queue, while workers complete the jobs and provide the results. The primary emphasis is on tackling worker node heterogeneity and mobility issues, such as nearby mobile devices may have differing capabilities and can move. The project's goal is to show how task sharing between high processing mobiles can result in more energy efficient execution and faster task completion. Phase detection from photographs is the task assigned to the workers in the implementation. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. In software requirements, we have Python IDEL with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Generate Mobile Devices. This module involves creating virtual or simulated mobile devices which act as the nearby mobile devices in the Honeybee architecture. Since using real Android mobile devices for delegation may not be practical due to Wi-Fi connectivity requirements, the project utilizes simulation-based devices to represent nearby mobiles. Second module is Local Run Task. This module is responsible for handling tasks that can be executed locally on the source mobile device. It identifies tasks that do not require offloading to nearby mobile devices or mobile clouds, thus reducing the overhead associated with task delegation. Third module is Offload Task. This module is the core component of the work sharing algorithm. It involves the delegator, source mobile, offloading computational intensive tasks to nearby mobile devices, workers. The tasks are maintained in a queue and workers steal tasks from the queue for processing. And the fourth module is Task Execution Time Graph. This module generates a graph that illustrates the execution time of tasks. It provides valuable insights into the performance of the work sharing algorithm and helps identify bottlenecks or areas for optimization. The graph may display task execution times for different types of tasks, comparing local execution with offloaded tasks. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the images folder in which we have the test images which we have used during the execution of the project. This is the main code file. Double click on run worker.bat file to start workers application. So here we can see that workers started. This is run.bat file. Instead of executing a project in the command line interface, we have created Windows bat file to execute the project. Double click on run.bat file. So this is the graphical user interface. We have created this GUI by using Tkinter in Python. By using this GUI, we will interact with the project. Now select a mobile ID from the mobile drop-down box. So here I am selecting mobile ID has 4. Now click on Generate Mobile Devices to generate the mobile devices. So here we can see this blue color circles represent the mobile devices and this red color represents the source mobile ID. Since I have selected 4 as mobile ID, mobile 4 will be considered as the source mobile ID. So we will find the mobile devices which are close to the source mobile ID. We can see that these blue color mobile devices are continuously moving. So the source mobile ID and the closest mobile devices to the source mobile ID will also continuously move and change. In the text view, we can see that this mobile devices which are closer to the source mobile ID, and these are also continuously changing. Now click on local run task to select the image and find the execution time in the local server. So here I'm selecting this image and open. So here we can see that only one face is detected and local task running time is 0.892 milliseconds. Now click on offload. We will just close this image. Now click on offload task to upload the same image. This task will be given to the workers and then we will find the execution time. I'm selecting the same image and open it. So we can see that only one face is detected. And here we can see the offloading execution time, that is 0.002 milliseconds, which is very less compared to the local task running time. Now click on extension compress and offload task. So here we can see the extension compress task offloading execution time. Now click on task execution time. So this is the task execution time graph. On the x-axis we have the technique name, that is local task execution time, offload task execution time, extension compress task time, and on the y-axis we have the values for these technique names. Now we will just close this graph, and the final conclusion for the project is: the project's conclusion emphasizes the efficacy of the proposed work sharing algorithm, the Honeybee architecture in reducing execution time and energy consumption by leveraging adjacent mobile devices for high computing tasks. The project effectively exhibits the potential of task sharing to provide energy efficient execution and faster task completion by dumping tasks to adjacent mobiles via the delegator and workers. Because nearby mobile devices may have various capabilities and movements, the project underlines the need of considering worker node heterogeneity and mobility. Overall, the result emphasizes the need of leveraging nearby mobile devices and the work stealing algorithm to optimize computing in mobile edge cloud systems. The use of face detection from photographs verifies the feasibility of the suggested method.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.